Welcome back to Part B. We are picking up right where Part A ended. Let's continue. Question 8. Show that root 3 plus I all to the 96th power equals 2 to the 96. The clean root is modulus argument form. The modulus of root 3 plus I is the square root of 3 plus 1, which is 2, and its argument is pi over 6. By de Moivre's theorem, raising to the 96th power raises the modulus to the 96 and multiplies the argument by 96. 96 times pi over 6 is 16 pi, 8 full turns, so the angle part comes back to 1. That leaves exactly 2 to the 96. Question 9. Show that the set A of all triples minus 2x, 0, 5x for real x is a subspace of R3. There are three things to check. The zero vector belongs, and the set is closed under addition and under scalar multiplication. Taking x equals 0 gives the triple 0, 0, 0, so the zero vector is in A. Adding two members with parameters x and y gives minus 2 times x plus y, 0, 5 times x plus y, again of the same form, so it stays in A. Multiplying a member by a scalar k gives minus 2 times kx, 0, 5 times kx, also of the same form. All three conditions hold, so A is a subspace. Geometrically, it's a straight line through the origin. Question 10. A geometric progression. The sixth term is 8 times the third, and the seventh plus the eighth is 192. For part A, the nth term is a times r to the n minus 1. The sixth over the third gives r cubed equals 8, so r is 2. For part B, the seventh plus eighth is a r to the 6 plus a r to the 7, which is a times 64 times 3 equal 192, so a is 1. For part C, with first term 1 and ratio 2, the 5th to 11th terms are 2 to the 4 up to 2 to the 10. That geometric sum is 16 times 2 to the 7 minus 1, which is 2032. Question 11. Every two people shake hands once, and there are 66 handshakes altogether. How many people are there? A handshake is just a choice of two people from the group, so the number of handshakes is n choose 2, which is n times n minus 1 over 2. Set that equal to 66. N times n minus 1 over 2 is 66, so n times n minus 1 is 132. That gives n squared minus n minus 132 equals 0, which factors as n minus 12 times n plus 11. The count must be positive, so n is 12. There are 12 people. Question 12. Find the integral of the square root of 1 minus sine ax. A root over a sine looks hard, but there is a neat identity. 1 minus sine x equals cosine of x over 2 minus sine of x over 2 all squared. So the square root is simply cosine of x over 2 minus sine of x over 2 with no root left. Integrating that gives 2 sine of x over 2 plus 2 cosine of x over 2. So the answer is 2 times sine of x over 2 plus cosine of x over 2 plus c. Question 13. Evaluate the integral of x times e to the x from minus infinity to 0 and say whether it converges. Integration by parts gives the antiderivative e to the x times x minus 1. Now evaluate between minus infinity and 0. At the top, x equals 0, we get e to the 0 times minus 1, which is minus 1. At the bottom, as x goes to minus infinity, e to the x shrinks to 0 far faster than x minus 1 grows, so that term vanishes. The result is minus 1, a finite number, so the integral converges. Question 14. Find the mean value of 5x squared minus 4x on the interval from 1 to 3. The average value of a function over an interval is 1 over the width of the interval times the integral across it. The width is 3 minus 1, which is 2, so we need 1/2 times the integral from 1 to 3. Integrating 5x squared minus 4x gives 5x cubed over 3 minus 2x squared, and from 1 to 3 that comes to 82 over 3. Half of 82 over 3 is 41 over 3, about 13.67. Question 15. Find the ellipse with a focus at 1, 0, and matching directrix the line x equals 4. For a conic centered at the origin, the focus sits at c equals a times e, and the directrix is the line x equals a over e. Here the focus gives c equals 1, and the directrix gives a over e equals 4. Multiplying c equals ae by a over e equals 4 gives a squared equals 4, and then e is 1/2, less than 1, so it truly is an ellipse. Now b squared is a squared minus c squared, that is 4 minus 1, which is 3. So the ellipse is x squared over 4 plus y squared over 3 equals 1. That brings us to the end of part B. The paper continues in part C. Open part C next and keep going. We pick up exactly where we left off. See you in part C.